Okay, so the next important idea when it comes to using templates is this idea of template specialization, right? We write a template, it specifies a pattern, it expects maybe some type to be matched to apply the pattern. And that process that the compiler, when the compiler decides to use a template in a specific context is called template specialization. And at that moment, the compiler generates a definition with all the types or template parameters set to very specific values. Like, for example, for that max function we talked about before, when the compiler decides to specialize max at a given call site, it will say, oh, that t equals int, or that t equals double. And then it generates a specialized version of that function under the assumption that t has a very specific type. So coming back to this example again, like at this first, this is our max function. And here we call it with 34 and 55. At this call site, what we would say is that the compiler deduces that t should be equal to int, right? The compiler deduces that t equals int. And then it produces a function where we replace t with int. Okay, the second call, the compiler deduces that t equals double, and then it creates a function, a version of max where t is equal to double. And it's important to note these are two different functions. Okay, it's not using one function and doing some sort of smart cast. It's not doing that. It's like there are two completely different functions in our program now. One with max that's specialized to int, one with max that's specialized to double. Under the hood at the assembly level, they would actually have totally different names, and they would take up different locations in memory, right? And technically they work differently because a comparison on integers is not the same thing as a comparison on doubles. At a minimum, at the hardware level, those are different instructions that work differently. And so there have to be two different versions of the code here. And that's actually what happens. We get two completely different versions of the code. But what's interesting here is we only had to write one version of the code, and the compiler made both of the other versions of the code for us. Now, one way we often write what this specialization is we would write the name of the function, and then in brackets, we would specify that specialization. So we'd say t equals int or t equals double to indicate this is what the compiler deduced. It deduced that at this first call, t was equal to int, and at the second call, t was equal to double. Templates are not declarations, right? Templates are a plan for how to create a function. They're not a function that already exists. They're just a plan for how to make one. And the compiler doesn't generate a bunch of functions in advance for how it might be used. It waits to see exactly how it will be used. And then it generates a specialization exactly for how it's used, right? And then if like it realizes, oh, I need the version for ints multiple times, it still makes only one version of that function. And it will use the same version of that function everywhere it wants to call max on ints. And then everywhere it wants to, we want to call max on doubles, it has a different version of the function that only calls on doubles. But if we then added another place in our code that called max on characters, we would create yet a third version of our code to work on characters. But we wouldn't make that character version until we saw a call somewhere in the program requesting it. The templates don't just generate everything you can in advance. It's very lazy, and the compiler only uses the template when it needs to use the template to generate some code. Okay, so in summary, template specialization occurs when a compiler decides to use a template and deduces the types involved. In the case we looked at here, we deduced that t should be equal to int in one case and that t should be equal to double in the other case. Okay, the compiler creates a single declaration for each specialization of the template. And then each of those specializations become part of our program. So we actually have two max functions in the program that I showed you. But fortunately, we got that from one template, from one pattern.